Prove that for all natural number n at least 12, P of n is true. So P of n is a statement that exists k and l, two natural numbers, such that 4 times k plus 5 times l is equal to n. So we need to show that for any natural number n at least 12, this is true. There exists something k and l such that n can be factorized, written as this form. Okay, so we use strong induction. So here's one way. So to use strong induction for this exercise, we consider n equal to 12, 13, 14, and 15 first. Okay, n equal to 12. We need to show that P of 12 is true, meaning that we need to show that 12 can be written of this form, right? There's some k and l such that 12 can be written as 4 times k plus 5 times l. So k equal to 3, l 0. So 12 equal to 4 times 3 plus 0, which is true. Similarly, we do it for 13. For 13, it can be written of this form as 13 equal to 4 times 2, which is 8, plus 5 times 1. So this is also true. So P of 13 is true. P of 14 is 14 equal to 4 times 1 plus 5 times 2. So 4 plus 10. 14 equal to 4 plus 10. This is true. So 14 can also be written as this form. 15 can also be written as this form, as we choose k is 0 and l is 3. So 15 is 0 plus 15. Okay, we good. Now suppose that, okay, we did prove it for all 12, 13, 14, 15. Now let n is at least 16. We want to show that it's only true for any n at least 16, right? So we do it by induction. Suppose that for any natural number t greater than or equal to 12, less than n, P of t is true. Here I use strictly less than n. You can use less than or equal to n, but be careful with considering all the case. So here we have all the cases at n at least 16, right? So on t from 12 to n minus 1, right? Because less than n, so on t from 12, 13, 14 until n minus 1, P of t is true. We suppose that P of t is true for any t between this, from 12 to n minus 1. T can be written as 4k plus 5l. We need to show that P of n is also true, meaning that n can be written as that form. Here I use k prime and l prime because I want to avoid using the same notation when we are in the inductive step. So come back to the note, we consider all the case possible, right, for n, because up to 15 we already know is P of n is true, right? So now we have from at least 16, we want to show that P of n is true for n at least 16. So here we have n equal to n minus 4 plus 4. Since n is at least 16, we know that n minus 4 is at least 12, right? So n minus 4 is at least 16 minus 4, at least 12. So we know that n minus 4 is greater than or equal to 12, strictly less than n. So by inductive hypothesis, we know that P of t is true. So in our case, t equal to n minus 4. So P of n minus 4 is true by inductive hypothesis, meaning that there exist two natural numbers k and l such that n minus 4 is written as 4k plus 5l. So now we have n equal to n minus 4 plus 4. Right. N equal to n minus 4 plus 4. Didn't change anything, right? Minus 4 cancel out with plus 4. So n minus 4 by inductive hypothesis is 4k plus 5l plus 4. So this is 4k plus 1 plus 5l. So k prime we can choose to be k prime can be chosen as k plus 1, and L prime is just L. So P of n is true because n is written and can be written as 4 times something plus 5 times something, where something here is our own natural number. So we know that they are at least 0, right? So there might be other way to do it, but be very careful here that on this number k prime l prime must be at least 0, because in the condition we have here the statement said that there exists natural number k and l. Okay, so therefore we just show that P of n is true, and then by strong induction we prove that for any natural number and at least 12 P of n is true, and we are done.